How do I start?
Domain.
Domain.
Oh, so you start by factoring.
Start by factoring. Okay, what can I factor?
X squared minus 4.
Okay, what's that going to turn into?
X plus 2 and X minus 2.
Good, because it is a
Conjugate.
conjugate. Beautiful.
And on the bottom, you can take the 4 out.
We get that out of 4. Good, that's the greatest common factor. What does that leave me with?
X plus 3.
X plus 3.
I'm on a roll.
Like butter on a roll. Alright? So what is your domain?
X cannot equal negative 3.
Why can x not equal a negative 3? How'd you get that?
Because we make X equals to 0.
You're saying if x plus 3 cannot equal to 0, and you're solving it. Okay?
Yep.
Yeah?
Mm-hmm.
Okay. Do I have any holes in my graph?
No.
Why not?
Because nothing cancels out from top and bottom.
Beautiful. Nothing cancels out.
Wait till I get to the bottom, though. I don't remember.
Okay. How about vertical asymptotes?
X is equal to negative 3.
Good. These guys are connected, right?
Yes, ma'am.
And a couple people were asking some really good questions about this. So the way that I remember it is vertical asymptotes cross which axis?
The X.
The x. If I draw a vertical line, it's always going to cross that x-axis. So I'm saying what x equals. Well, I know what x doesn't equal. That probably is where my asymptote is then. Does that make sense? Yeah. Whatever your domain isn't, and it's not a hole, is your vertical asymptote. If there was a hole at negative 3, then I'd have no vertical asymptote. If I had a couple different points in my domain that were taken out, and one of them was a hole, the rest of them would be vertical asymptotes. Okay, great question.
What would be a part of the domain?
4 wouldn't be a part of domain. That's an excellent question. Why is 4 not part of my domain?
Because it's not a term.
What? It's not
There's no X.
a variable.
Yeah, there's no variable, there's no x. Right, because what we're doing is we're setting our denominator equal to 0. So if I do 4 does not equal 0, well, that's a true statement, but there's no variable to say what it is. Does that make sense?
Yep.
Excellent. Very good. You guys are awesome. Having great questions here.
Loving it.
If you do it, if you keep it in a standard that is regular, then you subtract 12 and divide by 4.
Yeah. Since we're only taking out a number here, you could do 4x plus 12 does not equal 0 and just solve it, and you're still going to get negative 3. Very nice. Good tip. I like it. You should definitely go back and watch this warm-up video.
Yeah.
Good question. This is a good one. All right. How about horizontal asymptotes? Those ones are a little weird. How do we check for those? Greatest x. Yeah. What's my highest exponent here? X squared. So I'm comparing my coefficients of my x squared. How many x squareds do I have in the numerator?
1.
How many do I have in the denominator?
0.
I have 0 of them. 1 divided by 0 is?
Undefined.
Undefined. So how many horizontal asymptotes do I have? None. Yeah?
So, then the asymptote would be 0 if it was like 0 over 1.
If it was 0 over 1, then the asymptote would be at 0. Yes, very good. So since there's no horizontal asymptotes, that's when you have to check for slant or some other type of asymptote. Okay?
Oh, yeah, now I remember.
Yeah? I'm going to pause on that real quick. I want to do the intercepts first. Okay? You okay with that?
Yes.
Let me just get a little more space. So talk to me about, you can do either intercept. Which one do you want to do first? You want to do the x-intercept? Okay. If I know x-intercept, what do I know about my coordinate?
There's going to be a 0.
0 in for y. Good. So if I set 0 in for y here, what are you going to do?
Plus, make it equal to 0.
You're going to make it equal to 0. So what happens to my denominator then? It's going to get multiplied by 0, which means gone, right? Okay. So I really just care about what? Your numerator. So you want to take your x plus 2 and set it equal to 0, and you want to take your x minus 2 and set it equal to 0. So I have 2 x-intercepts. Where are they?
Oh, right. I don't know why.
-2 and +2. Very good.
I don't know why.
Yes. Always the numerator. Yep. Yep. Just like you do for domains, with the denominator, it's the same process with x-intercepts. Okay? Keep in mind with x-intercepts, you do want to use the simplified version, but since there was no holes, we didn't have to worry about it. Right? Cool. Alright, how about y-intercept? What do you know about your coordinate for your y-intercept?
Otherwise, the X is going to be 0.
Your x is going to be 0. You're figuring out what number the y is. So what are you really doing here? Plugging in 0. So you got 0 squared minus 4 over 4 times 0 plus 12.
So negative 4 over 12 and then negative 1/3.
Negative 4 over 12, which reduces down to negative 1/3. Very nice. We're doing okay?
So then you would write that out, 0, 1/3.
Mm-hmm. Those are all coordinates that you are going to end up plotting that will help you. These are the easiest coordinates to find to help us plot this.
Don't use like the 0,
Okay.
maybe 1/3 for like the slant or something like that.
No.
So how do you? 'Cause I
How do
remember-
you find the slant asymptote? What do we have to do? Everyone's favorite, long division. No?
It's not my favorite, but I like them.
It's not my favorite, but it's not my least favorite.
Last year it was my favorite because I didn't know how to do synthetic.
That's okay. How do I set up my long division? What goes on the inside, what goes on the outside?
Denominator goes on there.
Denominator goes on the outside, good, that's what I'm dividing by. And what do I write on my inside? X squared plus 0x, good, minus 4. Remember, you gotta have every space. Long division is all about being nice and organized, right? And since it's division, you start with division, right? You're dividing x squared by 4x. What does that leave you with? 1/4 x. Do you see that? If you need to write the 1 in, make sure you do it. 1/4 x. And then we gotta see what we have left over, right? So what do I have to do now? We gotta multiply to see what's left over. So 1/4 x times 4x. Is that 1x squared? 1/4 x times 12 plus 3x. What's my next step? Subtraction. Boop, boop. Make sure you got those. You can always use another color if you need to. What do I get? Negative 3x. And then we bring down that minus 4, even though it's not really going to matter because we don't care about the remainder. Okay? And then we start over, right? We're doing division. I'm dividing negative 3x, dividing by that 4x. And what does that leave you with? Negative 3/4. And that right there, my loves, is the equation of a line. How do you feel there? Yeah? We're going to practice more of them today. Okay? We're going to finish up your packet either today or next class. Either way, it's fine.
Yeah.
Okay? Do you need a second with that, or can I sneak back over? Actually, I don't think I need to sneak over. I can see everything. Can we graph this?
Yeah.
Tell me what you know. What could I...
You know your y-intercept and your x-intercept.
Okay, we can plot those points. So I know I have
Negative 2, 0.
negative 2, 0,
2, 0.
2, 0, and negative a third. Somewhere there. Yeah? What else can we graph?
The asymptote.
Asymptotes. Yes, the asymptotes. Okay. So where do I put my asymptotes? Describe them to me.
Negative 3.
Negative 3 goes where?
On the x.
Crosses x at negative 3. So I've got an asymptote here. Okay? How do I graph my other asymptote? Yeah. Which one of these numbers is going to be lower?
1/4.
This guy's lower. Let me put it this way. Which one's closer to 0?
1/4.
1/3 is closer to 0, right?
Yeah, I think
So
that was
this
your
line is
first one.
going to be below,
Oh, I was.
you see that? You understand? So just make sure, right, that guy is lower. That's going to be really important for what we're going to do when we get into graphing. Well, this is just the y-intercept of the asymptote. It's not part of your graph, it's part of your, like, guiding lines. That's what asymptotes really are. And then what's my slope here? What's my slope? What's my slant?
Down 3, up, over 4. Up 1, over 4.
We know where our slope is in our line, right? Please don't give me probably a heart attack. Which one of these is your slope?
Oh. 1, 4.
One back.
Why is there a negative 3/4 and a positive 3/4?
Isn't it negative? Did you guys subtract? Yeah? Okay. Alright, so I'm going up 1 and over 4, right? Up 1 and over 4. Or I can go down 1 and over 4. And down 1 and over 4. Yeah. It's really starting at negative 3/4, but I wanted to make sure that it was lower than this guy. Okay? Because what's going to happen when we get into graphing these, and we'll either get to this part today or next class, is you can only have your graph one spot in each column. So it's either going to be down here or up here. It's either going to be down here or up here. And since you already know these points, you already know that your graph is going to go like that. Is that cool? Because you already know that there's points here from your intercepts, you know that your graph is going to live in this top section as opposed to this bottom section. Okay? Sometimes your intercept is going to be enough because you'll get an intercept over here as well. But what we're going to end up having to do is test a point to figure out where that's going to go as well. Okay? But the intercepts are definitely the easiest points to find. Okay? We're going to get there. Everyone breathe. We cool? Any other questions on this problem? Okay.
I get the negative 3/4. Because of negative 3.
So you're dividing negative 3x divided by 4x, and the x's knock out. Yep. Cool. Great question. All right.